Alright, in this video we're going to look at how we simplify rational expressions. First of all, a quick talk about what a rational expression is. A rational expression is a fraction. It contains polynomials in both the numerator and the denominator. Sometimes more complicated polynomials, sometimes simpler polynomials, but you notice that in each of these fractions we have a polynomial in each of the numerators. We have a polynomial in the denominators. And so these are rational expressions that we see right here. And the way we're going to simplify these, it's actually kind of a nifty process. If you think about how you simplify or reduce a fraction, just a plain old fraction like 5 over 10, you think about the factors that exist for 5 and the factors that exist for 10, and you cancel out any common factors that exist between the two. And the process for simplifying a rational expression is exactly the same. We want to come up with factors that are common between the numerator and the denominator. And we want to cancel out any that are the same. So the first step we're going to take in any of these is we're going to factor both the numerator and the denominator of the expression. And then we're going to look at the factors and see if there are any in common. So let's do a bunch of examples here just so we can see what's going on. All right, first one. Simplifying 5x minus 10 over x squared minus 2x. Our first task is going to be to find the factors of both the numerator and the denominator. So we look at the numerator, 5x minus 10. We can factor a 5 out of both of those, so a little GCF. And then we look at the denominator, x squared minus 2x. And again, we're going to take a GCF. We can take an x out of both of those. And once we're done doing that, we notice that we have these common factors. We have an x minus 2 in both the numerator and the denominator. And so what we're going to do is we're going to cancel those out. And what's left is our reduced version of this rational expression. So we have a 5 left in the numerator. We have an x left in the denominator. And so that is our simplified form of 5x minus 10 over x squared minus 2x. That's it. That's the big idea. Factor, factor, cancel. Rewrite your answer. All right, let's look at part B. We're going to factor the numerator. And this factors as x minus 1 times x minus 1. And then the denominator, x squared minus 1, that factors as x plus 1 times x minus 1. And we have a common x minus 1. We can cancel the x minus 1 from the denominator with either 1 from the numerator. It doesn't really matter. But we only want to cancel it with one of them. So we're going to cancel those out. And then we've got our reduced form. We've got what's left in the numerator over what's left in the denominator. It's really important for you to get a lot of practice in on factoring, because the easier you can factor any polynomial that appears in these rational expressions, the easier it's going to be for you to simplify the rational expression. All right, let's look at part A. So we're going to factor, again, numerator and denominator, x squared plus 2x minus 15. It's going to factor as x plus 5 times x minus 3. And the denominator, that's going to factor as x plus 2 times x minus 3. If you need a little bit of time, to figure out and make sure you understand how those factorizations are coming about, just go ahead, pause the video, think about it for a second, and make sure you see why these are our factorizations. And again, we see that there's a common factor in x minus 3 in both the numerator and denominator. Those will cancel and leave us with our final answer of x plus 5 over x plus 2. All right, part B, let's see, this one factors as x plus 6 times x minus 2. The denominator factors as x plus 6 times x plus 1. The x plus 6 is canceled, and we're left with x minus 2 over x plus 1. Okay. A few more here. A little bit more complicated here in this batch. All right, so let's see. We're going to have to factor GCF out of both, in both the numerator and denominator here. We can factor a 4x out of the numerator. And we can factor an x squared out of the denominator. And now we still have two polynomials in both the numerator and the denominator that are factorable. And so we need to factor them more. The x squared minus 9 factors as x plus 3 times x minus 3. And the x squared minus 2x minus 15 factors as x minus 5 times x plus 3. And now we need to cancel out some common factors. We can cancel an x plus 3 and an x plus 3. The other thing you want to notice right here, we've got an x and an x squared. We can cancel an x from both the numerator and the denominator since they are factors now. So we'll get rid of the x in the numerator, and the x squared in the denominator becomes just a single x by canceling an x from both of them. And so let's see what we've got left behind. We've got 4 times x minus 5 left in the numerator, and in the denominator we have x times x minus 3. And that's the simplified form of that rational expression. All right, last one here. We can factor our numerator as x minus 8 times x plus 5, and our denominator as x plus 2 times x plus 4. And we notice here that there aren't any common factors between the numerator and the denominator. And so in fact, when we get done with this one, this rational expression is already in its most simplified form. And we can leave it either factored like that, or we could just leave it as the original problem. And that is the simplified form of this rational expression. All right, that's it for simplifying rational expressions. See you next time.